All right, let's keep going on brachiopods. You've seen this one before, right? And you've seen this one before. That's fine. Brachiopods get familiar after a while. And I show some of the same slides. What we're doing in this one, and this will be a very short one, is just going to intro how we are going to go and use a map like this, like so. That's going to list the different features. And so these features can be present or absent. And if they are present, they can be modified. Like sometimes they're really wide, they go all the way to the edge, or they go, or they're really small, like they only go 1/4 the length of the shell. If you can come up with a verbal description, a verbal set of rules for each character, then you can define different character states. And we'll get to character states. That's going to be the next lecture that we do. But this is how you're going to use those character states in order to make a description. And this is what we want to do. So describe a brachiopod in a way that we can actually use this to see if it's part of a species we already know, part of its own species, and if it is part of its own species, how to define that species based on its characteristics. So you got your outer parts, you got your teeth, you got your, ventral valve, and you got your dorsal valve interior parts. And then there's a couple characters that refer to the outside, but honestly, those are pretty similar across vaguely similar brachiopods. The real nitty-gritty differences are always on the inside of these things. So, we've already covered that. So let's just look at the description of a species, shall we? So let's make this ever so slightly bigger. There we go. There we go. All right, and look at some of these fancy words. So this is from a modified description that I have put together for a genus, the genus called Lysoconites, which is one that is very common here in Texas, so we have a lot of opportunity to study it and get really good at it. So, Lysoconites, and then you have to say who is the person who originally defined what Lysoconites is. In this case, it is Dunbar and Condra, 1932. Was their paper where they did that. And so a description is going to be a checklist of expected features. And it's going to mention development wherever possible or have a separate development section. So that's going to help us there. Yeah, sorry about that. All right, Lysoconites, let's go. We're going to go from posterior to anterior. We're going to start with the outside. That's going to be the general. And then we're going to go with the interiors of both valves. So usually they have a size thing here at the front, and I kind of hate it, but it does help in some cases. There are a few of these shells that can grow to large sizes. So when they're talking about size, they mean the maximum size it can reach. Now, did all of yours die at a very young age compared to some of the other ones? It's possible. So I would say the first thing in a description, usually you've got to take with a grain of salt. But what we're doing here with this word, conitoids, is we're saying it belongs to a superfamily or a suborder, I can't remember, Conitoidea, or Conitidna. And these shells have certain characteristics. There's a definition for that suborder. And so what you're saying here is, yeah, everything that's true about conitoids is true about these things. So bam, right up to there, you have filled in all those parts. And then you'll go on to say, and here's what makes it different. So it's nice to drop one of those taxonomy words into the beginning because it saves you a lot of writing for things that are not going to change on any member that is within that group. So there's your shorthand. So these have a smooth surface, and it's actually got a layer on the top that has where the little surface spines used to be. And that's going to be a smooth layer, whereas it's got big ridges in it in a lot of other related brachiopods, related conitoids. Low profile means it's almost completely flat. So that's a fancy way of saying that. Outline, you try and throw a word on it because some of them are very long, some are very wide. So arcuate is a word which means it's like a semicircle. It's like a big arc. So it can be flat on the top, but it's got a sort of a circle on the bottom. So arcuate to subtrapezoidal. Sub means not quite. And so a trapezoid is, well, it's this shape. Angle on the side, it's like a triangle you chop the top off of. Angle on the side, flat across the bottom. Angle on the side, flat across the top. Yeah. Quadrilateral, where the sides do this and the top and bottom do this. And yeah, I think that's a reasonable explanation. It's somewhere between those two at different stages of its growth. Okay, the dorsal side on conitoids is going to be flat to concave. In this case, it's fairly flat. They're almost just, one side is convex and the other side is just sort of flat, but slightly concave. So that's what low concavity means. Yeah. Ventral sulcus. So on a lot of these, there's that dip. Remember, the dip is the thing that's either smiling or frowning in the center? That's the sulcus. And the sulcus is going to be on the ventral side. So on the ventral side, there's going to be a little dip. If you flip it over so the ventral is on top, it'll look like that. Yeah, kind of like that. There we go. Not good at those TikTok hand gestures. And in this case, the sulcus is very low, so it's shallow, which would be another good word to use, and relatively wide. There are some that have a real sort of pinched, like V-shaped crevice down the middle. And you would say for those that the sulcus is deep and narrow as opposed to low and wide. Yeah. Let's see, or shallow and wide. Orthomorph. So we're talking about the spines. And sometimes spines curve and sometimes spines are straight. And so if they're straight, we say they're orthomorph. Yeah, straight shaped. Cardinal spines are the spines that run along the hinge. So there we go. And they can be up to half as long as the valve itself, like the entire shell. So if the shell's this big, the spines will actually be that big if you can find them intact. And so this means we have a specimen where those are intact. And that is what has allowed us to actually make this generalization. Yeah, which is pretty cool. Yeah, so we can add to that. All right. The inner spines, closest to the center, the midline, are pretty much straight. And the outer spines are going to be tilted like that. And so that's going to be fairly common as well. And that is what we're saying here. Inner upright, inner spines upright, outer oblique. Notice the use of semicolons. Semicolons separate different parts of the shell. Commas separate different characters found within that part of the shell. And a species description is going to be written in what is called telegraphic style. Telegraph is that little thing like SOS, the Titanic is sinking. Yeah, like that. When you used to send messages by telegraph, you had to pay by the letter or space, pay by the character. And so people would write really short messages that were very brief and very condensed. And that's what species descriptions are supposed to be. So we can fit a lot of them into a book. And so they have all the information and none of the fluff. And so that's why this is written in a telegraphic style. All right. We're doing great? Okay. All right. So this semicolon says we're going to be talking about the cardinal spines in this section. And so they're orthomorph cardinal spines. We could say cardinal spines, comma, orthomorph, comma, up to half the valve length, so that's the length of the spines, is a separate character, comma, the inner spines are upright, so like pointing perpendicular to the hinge, yeah, so okay. The outer ones are oblique. Oblique means tilted away from the hinge, like, yep, got it. And the spines on the valve, like the middle of the shell part, are very short and hollow. And yeah, that's true. So we've covered all the spines in one little section. And we could have set off the body spines, like the valve spines, with a semicolon. That would be another way to do it. Yeah, reasonable way to do it. Actually, let's do that. Let's edit this description. There we go. All right. And let's move orthomorph over. So cardinal spines are orthomorph, comma, up to half valve length. Yeah. And then it all refers back to the first thing. And instead of low and wide, we can say ventral sulcus low, comma, wide. There we go. And we just saved ourselves four characters worth, 4 cents or something on our message. Good job. Good job, telegraph operators. All right. Whew, that's a lot. But now let's go to the interior. So we've got hinge teeth. And the hinge teeth on this one are short relative to other members of the conatoids. That's a relative designation, and so I don't really like that, but it's part of the original description, and it is true. They're short, and I think the more important thing is that they are curved. They curve along. So like these are like rectangle teeth, and the part that locks into the other valve is flat on the bottom. In Lysoconides, it's curved. It's just a little curve like that. Okay, apical callosity is this little bit up here. It's like the socket that the hinge is going to rotate against as it opens and shuts. And so this one's fairly short on this one. So it's this sort of peach part right up here. Ventral median septum, and we've got that colored correctly. That's right here on the ventral valve. Is going to be short, which we will define elsewhere as being about half the length of the shell or shorter. Yeah. It's only long when it's longer than that, and this is based on looking at a lot of them. They're all either half length or full length, basically. Yeah. Or you would have very short for the ones that are just like underneath the apical callosity and they just stop right there. And you'd have a separate category saying that's like 1/4 length or less. The interarea is the flat bit in between the two shells. And so the interarea of the ventral valve is going to be this sort of brownish thing up here. And so that's relatively short as they go compared to something like a Billingzella, which has a very long one. It's just ridiculously long. Apsicline refers to the tilt of the hinge. So this means that if the ventral valve is like this, the hinge is going to be tilted in this particular orientation. Okay, the diductor scars are going to be weak. So that's going to be these scars right here, this sort of big blue thing, and it's shown like really big on there. That's bigger than you get in any of them. But in this case, they don't leave a big groove in the shell, so you say the scars are weak. Yeah. Flabellate means it has sort of fingers on the ends like this, which, yes, it does. Anterolateral rim, so that's our anterolateral rim right here. And so that has little tiny granules, like little bumps in radial rows. So they're arranged in rows. The rows would all point toward the nose of the shell, right up here. All right, whew, doing great. Dorsal anterior. We're going to start up here at the posterior again. So we went posterior to anterior, and we're going to start at the posterior. This bit that sticks out, that forms the hinge, and is the part that rotates along there, like the little, the ball part of a ball and socket joint, basically, is going to be short compared to other members of its group. Shallowly excavated, so we're talking about the hole that's behind it. Sometimes it's a giant pit, or but in this case, it's just like a gradual slope. And then the pit behind it, so there's not much of a drop-off between the dark green and the orange. This is saying that the antron, which is the central orange bit, is going to be relatively shallow, so it's not a great big deep pit. And that's where like the body and the mouth of the organism, we think, would have been. The rim, some of these have a big rim on the antron, but this genus doesn't, so the rim is absent. Inner socket ridges, which are going to be these guys right here, are going to be short. They sometimes extend all the way to the end of the valve. And so we'll define short somewhere else as being like no more than a quarter the width of the shell or something like that of the valve. Adductor dividing ridges. So there are inner and outer adductor, like muscle scars, two sets on conatoids. And so here are the outer ones, here are the inner ones right here along the middle. The inner ones are this bluish color, the outer ones are kind of like pinkish meat colored. Yeah, gross. The ridges that divide those are this sort of purplish thing, and those are low to absent. There's basically nothing, no wall separating these two muscles, whereas there's a giant wall in some other brachiopods. The two little prongs that are here, those are called the andoridia, and those are not connected by a ridge to the antron. It's just like they're sitting on the floor, sort of pointing up like that. And they're two little finger-like projections. We're not sure what they're for, but they're part of the description because they're part of the fossil. Yeah. Okay. Dorsal, median, breviseptum. That's a lot. Dorsal valve. Median septum runs down the middle. Breviseptum because it's not connected to the cardinal process, which is the green bit up here. It like flattens out and then it comes back later on. So the dorsal brevian median septum goes to about mid-valve, so it only goes to about here. This one's shown as a very long one. And it tapers. It goes back down as you get toward the anterior, whereas there's some that'll come up to a big spike toward the anterior. And this one tapers at both ends, so it's like a little polite hill-shaped, and it's just a thin sort of blade of secondary shell. Brachial platform. So this is where the arms used to sit. So here we're talking about, all right, is that raised up off the floor? And in this case, it is not. It's just covered in little rows of granules. I would say if it was raised up, it had like a wall there. That's the brachial ridge, would be the marker that shows exactly where the arms used to be, and that is absent here. We cannot find that. But on some brachiopods, it's very prominent, in older ones especially. And so, yeah, it's a thing that you can tell them apart with. And then lastly, the developmental characters. So the posterior of one valve is going to have a diamond-shaped fold on the dorsal valve. And it's going to flatten out. And the outline is originally almost square, roughly. And then by the time it puts in its first spines, so here they are, the first cardinal spines along the hinge, then it's going to start to metamorph, and it's going to start to get wider relative to length. Oh, and that's a little heart. Isn't that adorable? Okay, fine. And then once it gets to a certain point and it has grown to full maturity, it enters old age, which is gerontic growth right down here. And at gerontic growth, it basically stops growing wider and it just grows longer. Yeah. So like various parts of people that just grow longer as they get older. There you go. Gerontic lengthening. It happens to all of us. Don't worry about it. It's no big deal. Yeah. All right. There you go. And so there's your little cheat sheet that has all the parts in all the colors, and we'll put that up on the board, and we'll look at some brachiopods, and we'll see if we can come up with some kind of description. And there are some words that I didn't use. I would mark them if they're present, because these are rare things that are only in certain groups. And there are other words that are always there, and so you want to say what kind of version of this feature is going to be present in this particular shell. That's how you make a good description. A good description hits all the details, and a good description is going to be based on not just one type specimen, but a whole great big collection. Different ages, inside, outside. You want to look at a bunch of these things, and you want to see what are the parts that do not vary, at least within a particular age. And then those are going to be things that are useful. And if there are parts that vary from one individual to another, or slight variations, you want to make sure those do not enter your species description, because they're just, like height in humans. There's a range, and it doesn't really matter. Yeah, height is just a number, baby. Yeah. All right. There you go. That is how you write a good description, and that is what we will practice in class. I think you'll understand brachiopods even better by the time we get done with that. I think there's kind of no way that you won't. So there you go.